Okay, so a little bit of quadratic inequalities just to try and help you along here. So step one was to solve equals 0. So we've got x squared minus 5x plus 6, everything on one side, great, equals 0. Okay, and then for this one we could actually think about splitting the middle term. So this is a 1 here, so it's 1 times 666, and we've got negative 5. So we split the middle term, two numbers multiplied to give 6. But add to give negative 5. So I think that's 3 times 2 is 6. Negative 3 times negative 2. Perfect. Negative 3 times negative 2 is positive 6. Negative 3 subtract 2 is negative 5. So we do x squared minus 3x minus 2x plus 6. We split the middle term. Factor out an x here, x minus 3. Then factor out negative 2 here, x minus 3 equals 0. Now you can see the x minus 3 is common, so it's x minus 3 is a factor, and you've got the x minus 2 here equals 0, therefore you've got x equals to 3 or x equals to 2. Now these are the two zeros for the graph of y equals x squared minus 5x plus 6. So we've got y equals, we've got 2 here, and we've got 3 here. So we just go ahead and draw the graph. All we need to see the zeros, and now we're looking at, well, which x number, when I feed it into the equation, produces a y number that's less than or equal to 0, okay? Well, this is the part of the graph that has outputs less than or equal to 0, okay? So it's actually one part that's connected, so it's this section on the number line, any x number between these 2 points, between 2 and 3, if I feed it into here, I am going to get an answer less than 0, okay? So now let's put that in the final answer. We've got a 2 here, we've got a 3 here, and notice that it's connected on the number line. So put the x in the middle, and then just transfer down the same signs going the same way from the original question. So basically x is between the values of 3 and 2, and we can have 2 and 3 included as well, okay? Second question to practice is this one. Okay, so let's go ahead and x squared plus 4x minus 5 equals 0. I'm not going to split the middle term here because when we've only got 1x squared, we should be able to guess the numbers quite quickly. It has to be 5 times 1 to give 5. One of them has to be negative, and one of them has to be positive. So can you see that? That would be x squared. That would be plus 5x. Minus 1x would be minus plus 4x, that's correct, yeah? And then minus 1 times by positive 5 would be negative 5, so that would work. So now we've got x minus 1 equals 0, or x plus 5 equals 0, so x equals 1, or x equals negative 5. Go ahead and draw the graph. Negative 5 is here, 1 is here. Draw the graph of y equals x squared plus 4x minus 5. Well, we know it's concave up, so it has to do something like this. And now let's go and highlight the section we want. Well, we now want, when is the graph actually greater than a height of 0? So it's actually, in this part of the graph, these are the branches that are higher than 0. So it's these x values we want here. Anything greater than 1, when we substitute it into here, gives us a value greater than 0, and anything less than negative 5 here works. Now because these are two separate sections of the number line, we write it as two separate inequalities, x greater than 1 and x less than negative 5, okay? We can just check that, so any number of x that's along here or any number of x that's here should make that top inequality true. So let's choose maybe 3. Let's choose an x value of 3. If we substitute it in, 3 squared plus 4 times 3 minus 5, if you work that out, you'll find that's 9 plus 12 minus 5. Well, that answer is definitely bigger than 0, isn't it? That works, okay? If you test any number in this section, it won't work for the inequality. So should we test a number there? Let's maybe test this number here, which is 0. Okay, let's feed 0 in. 0 squared plus 4 times 0 minus 5. Well, if you work that out, that's negative 5. Is negative 5 greater than 0? No. Okay. So that's kind of how it works and how we use the graph to help us find the full solution set.